The initials GPT stand for Generative Pre-trained Transformer. So that first word is straightforward enough. These are bots that generate new text. Pre-trained refers to how the model went through a process of learning from a massive amount of data, and the prefix insinuates that there's more room to fine-tune it on specific tasks with additional training. But the last word, that's the real key piece. A transformer is a specific kind of neural network, a machine learning model, and it's the core invention underlying the current boom in AI. What I want to do with this video and the following chapters is go through a visually driven explanation for what actually happens inside a text, including what it just added. I don't know about you, but it really doesn't feel like this should actually work. In this animation, for example, I'm running GPT-2 on my laptop and having it repeatedly predict and sample the next chunk of text to generate a story based on the seed text. And the story just doesn't actually really make that much sense. But if I swap it out for API calls to GPT-3 instead, which is the same basic model, just much bigger, suddenly, almost magically, we do get a sensible story, one that even seems to infer that a pie creature would live in a land of math and computation. This process here of repeated prediction and sampling is essentially what's happening when you interact with ChatGPT or any of these other large language models, and you see them producing one word at a time. In fact, one feature that I would very much enjoy. Let's kick things off with a very high-level preview of how data flows through a transformer. We will spend much more up into a bunch of little pieces. These pieces are called tokens, and in the case of text, these tend to be words or little pieces of words or other common character combinations. If images or sound are involved, then tokens could be little patches of that image or little chunks of that sound. Each one of these tokens is then associated with a vector, meaning some list of numbers, which is meant to somehow encode the meaning of that piece. If you think of these vectors as giving coordinates in some very high-dimensional space, words with similar meanings tend to land on vectors that are model in the phrase a machine learning model is different from its meaning in the phrase a fashion model. The attention block is what's responsible for figuring out which words in the context are relevant to updating the meanings of which other words, and how exactly those meanings should be updated. And again, whenever I use the word meaning, this is somehow entirely encoded in the entries of those vectors. After that, these vectors pass through a different kind of operation, and depending on the source that you're reading, this will be referred to as a multi-layer perceptron or maybe a feed-forward layer. And here, the vectors don't talk to each other. They all go through the same operation in parallel. And while this block is a little bit harder to interpret, later on we'll talk about how the step is a little bit like asking a long list of questions about each vector, and then updating them based on the answers to those questions. All of the operations in both of these blocks look like a giant pile of matrix essays based on an initial snippet. To make a tool like this into a chatbot, the easiest starting point is to have a little bit of text that establishes the setting of a user interacting with a helpful AI assistant, what you charm as the first large language model to really capture the world's attention outside of ML communities. Also, practically speaking, companies tend to keep much tighter lips around the specific numbers for more modern networks. I just want to set the scene going in, that as you peek under the hood to see what happens inside a tool like ChatGPT, almost all of the actual computation looks like matrix vector multiplication. There's a little bit of a risk getting lost in the sea of billions of numbers, but you should draw a very sharp distinction in your mind between the weights of the model, which I'll always color in blue or red, and the data being processed, which all being processed simply encodes whatever specific input is fed into the model for a given run, like an example snippet of text. With all of that as foundation, let's dig into the first step of this text processing example, which is to break up the input into little chunks and turn those chunks into vectors. I mentioned how those chunks are called tokens, which might be pieces of words or punctuation, but every now and then in this chapter, and especially in the next one, I'd like to just pretend that it's broken more cleanly into words, just in machine learning, long before transformers. But it's a little weird if you've never seen it before, and it sets the foundation for everything that follows, so let's take a moment to get familiar with it. We often call this embedding a word, which invites you to think of these vectors very geometrically, as points in some high-dimensional space. Visualizing a list of 3 numbers as coordinates for points in 3D space would be no problem, but word embeddings tend to be much higher dimensional. In GPT-3, they have 12,288 dimensions, and as you things that a simple model is giving me, I'm going to do an analogous thing by choosing a 3-dimensional slice through this very high-dimensional space and projecting the word vectors down onto that